For testing above 50 volts with low current, several standards and best practices should be considered to ensure worker safety and prevent equipment damage. Firstly, ANSI/ESD S20.20 2014 addresses the protection of electrical equipment from electrostatic discharge. It mandates the testing of voltages exceeding 50 volts employ a test fixture or jig specifically designed to prevent operator contact with exposed live parts. It also specifies that personnel handling such test equipment receive proper training and utilize appropriate personal protective equipment, commonly referred to as PPE. Secondly, ANSI/TIA 942, the telecommunications infrastructure standard for data centers, includes electrical safety considerations relevant to data centers. This standard addresses testing procedures and PPE requirements, emphasizing that personnel working with exposed live parts above 50 volts must be both trained and authorized. Moreover, it requires the isolation of work areas and the use of barriers to restrict unauthorized access. Thirdly, ISO 61010.1 outlines safety requirements for electrical equipment used in measurement, control, and laboratory settings. It provides general safety guidelines for electrical test equipment, especially when testing at voltages above 50 volts. The standard dictates that equipment design must minimize the risk of electric shock and reduce the need for extensive protective measures for operators. Moving on to training and work area design, comprehensive training is essential. This training should encompass electrical safety hazards, detailed testing procedures, PPE requirements, and emergency response protocols. Qualified personnel should deliver this training, ensuring it is regularly updated to reflect the latest safety standards and practices. Practical hands-on practice and simulations are vital components of the training program, confirming that participants thoroughly understand and can competently apply safety procedures. Regarding work area design, several critical elements should be incorporated. Firstly, work areas should be isolated and access restricted to authorized personnel only. This isolation minimizes the risk of accidental exposure to electrical hazards. Secondly, barriers should be strategically placed to prevent accidental contact with exposed live parts. These barriers act as a physical safeguard, significantly reducing the likelihood of electrical shock. Thirdly, prominent warning signs should be displayed to alert individuals to the presence of electrical hazards. These signs should be clear, concise, and easily visible. Fourthly, adequate ventilation is necessary to prevent the buildup of hazardous gases. Proper ventilation ensures a safe and healthy working environment. Fifthly, grounding and bonding systems must be correctly installed and consistently maintained. Effective grounding and bonding are crucial for preventing electrical hazards by providing a safe path for fault currents. In addition to these standards and guidelines, many organizations develop their own internal safety procedures and protocols tailored to testing above 50 volts. These internal procedures typically include specific requirements for PPE, work area design, training programs, and emergency response plans. It is highly recommended that organizations consult with industry experts and adhere to best practices to ensure the safety of their employees and equipment. Such consultations can provide valuable insights and help in customizing safety measures to specific operational needs. A well-designed safety program will often integrate elements from multiple standards and adapt them to the unique challenges presented by the organization's testing environment. The goal is to create a comprehensive safety culture that prioritizes the well-being of employees and the integrity of equipment. Some additional considerations for enhancing safety during high-voltage, low-current testing include implementing a lockout-tagout system to prevent accidental energization of equipment during maintenance or testing, regularly inspecting test equipment for damage or wear and tear, and replacing any faulty components promptly, providing employees with access to readily available first aid supplies and ensuring they are trained in basic first aid and cardiopulmonary resuscitation, also known as CPR, conducting regular safety audits to identify potential hazards and ensure compliance with safety procedures, encouraging employees to report any safety concerns or near misses without fear of reprisal. Implementing a system for tracking and investigating incidents and accidents to identify root causes and prevent recurrence. Using appropriate measuring instruments and calibrated testing equipment to ensure accuracy and reliability. Providing adequate lighting in the work area to improve visibility and reduce the risk of accidents. Ensuring that employees understand the proper use of personal protective equipment, including safety glasses, gloves, and insulated tools. Implementing procedures for handling and disposing of hazardous materials safely. Providing training on the proper use of fire extinguishers and other fire suppression equipment. Regularly reviewing and updating safety procedures to reflect changes in technology, regulations, and industry best practices. Creating a culture of safety where all employees are empowered to take responsibility for their own safety and the safety of others. Some specific examples of PPE that may be required for high voltage, low current testing include insulated gloves rated for the appropriate voltage level, safety glasses or face shields to protect the eyes from arc flash or other hazards, insulated tools to prevent electrical shock, and flame-resistant clothing to protect against burns. It is also important to ensure that all PPE is properly fitted and maintained. In addition to the ANSI, TIA, and ISO standards mentioned earlier, other relevant standards may include those from the Institute of Electrical and Electronics Engineers, also called IEE, the National Electrical Manufacturers Association or NEMA, and the International Electrotechnical Commission IEC. These organizations provide guidance on a variety of electrical safety topics, including equipment design, installation, and maintenance. To further elaborate on work area design, consider implementing visual cues such as color coding to identify different voltage levels or hazard zones. This can help employees quickly assess potential risks and take appropriate precautions. Also, consider using physical barriers such as fences or walls to separate high voltage testing areas from other work areas. This can help prevent unauthorized access and reduce the risk of accidental exposure. Furthermore, ensure that work areas are kept clean and free of clutter to prevent trips, falls, and other accidents. In addition to formal training programs, consider providing employees with ongoing safety reminders and updates through toolbox talks, safety newsletters, and other communication channels. This can help reinforce safety concepts and keep employees informed of any new hazards or procedures. Another important aspect of electrical safety is proper grounding. Grounding provides a low-resistance path for fault currents to flow back to the source, which helps to prevent electrical shock and equipment damage. Grounding systems should be designed and installed by qualified personnel and regularly inspected to ensure their effectiveness. Moreover, bonding is another important aspect of electrical safety. Bonding involves connecting all metal parts of an electrical system together to create a common ground potential. This helps to prevent voltage differences between different parts of the system, which can reduce the risk of electrical shock. It is essential to understand that safety is not just a set of rules or regulations, it is a culture that must be cultivated and maintained. Creating a culture of safety requires the active participation of all employees, from top management to entry-level workers. When safety is a core value, everyone is more likely to take responsibility for their own safety and the safety of others. To help promote a culture of safety, consider implementing a safety incentive program. This program can reward employees for identifying hazards, reporting near misses, and participating in safety training. Also, consider establishing a safety committee that includes representatives from all departments. This committee can help to identify and address safety concerns and develop and implement safety programs. Additionally, leadership plays a crucial role in creating a culture of safety. Leaders must demonstrate a commitment to safety by actively participating in safety activities, setting a good example for others to follow. They must also empower employees to take responsibility for their own safety and the safety of others. When leaders prioritize safety, it sends a clear message that safety is a core value of the organization. In addition to the measures already discussed, regular audits and inspections are essential for maintaining a safe work environment. Audits and inspections can help to identify potential hazards, ensure compliance with safety procedures, and evaluate the effectiveness of safety programs. Audits should be conducted by qualified personnel who are familiar with electrical safety standards and best practices. The findings of audits and inspections should be documented and used to develop corrective action plans. It is also important to track and investigate incidents and accidents to identify root causes and prevent recurrence. Incident investigation should be conducted by a team of qualified personnel who are trained in incident investigation techniques. The findings of incident investigations should be used to develop corrective action plans and to improve safety procedures. Furthermore, it is essential to communicate safety information effectively to all employees. Safety information should be communicated in a clear, concise, and easy-to-understand manner. It should also be communicated in a variety of formats, such as written materials, presentations, and training sessions. Employees should be encouraged to ask questions and provide feedback on safety information. Additionally, it is important to keep safety information up to date. Safety standards and best practices are constantly evolving, so it is essential to review and update safety information regularly. One often overlooked aspect of electrical safety is the potential for arc flash hazards. Arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical system. Arc flash can cause serious burns, blindness, and even death. To protect against arc flash hazards, it is essential to conduct an arc flash hazard assessment. This assessment will identify potential arc flash hazards and determine the appropriate personal protective equipment and safe work practices to use. Arc flash hazard assessments should be conducted by qualified personnel who are familiar with arc flash standards and best practices. In addition to conducting arc flash hazard assessments, it is also important to implement arc flash protection measures. These measures may include using arc-resistant equipment, installing arc flash barriers, and providing employees with arc flash personal protective equipment. Arc flash personal protective equipment typically includes flame-resistant clothing, a face shield, and gloves. Proper selection and use of arc flash personal protective equipment is essential for protecting against arc flash hazards. Moreover, the design and layout of electrical equipment and systems can have a significant impact on safety. For example, equipment should be located in well-ventilated areas and should be easily accessible for maintenance and repair. Wiring should be properly installed and protected from damage. Grounding and bonding systems should be designed and installed in accordance with applicable standards. It is also important to ensure that electrical equipment is properly labeled with appropriate warnings and instructions. When working with electrical equipment, it is essential to use the right tools for the job. Tools should be properly insulated and in good working condition. Avoid using tools that are damaged or worn. Before working on any electrical equipment, always de-energize the equipment and verify that it is de-energized using a voltage tester. Follow proper lockout-tagout procedures to prevent accidental energization of the equipment. When working on energized electrical equipment, use appropriate personal protective equipment and follow safe work practices. Avoid working alone and always have a qualified person nearby in case of an emergency. Also, be aware of your surroundings and avoid distractions. It is also crucial to remember that electrical safety is an ongoing process, not a one-time event. It requires a continuous commitment to safety from all employees, from top management to entry-level workers. By implementing the measures discussed in this narration, organizations can create a safe and healthy work environment for their employees and prevent electrical accidents and injuries. Ultimately, the goal is to protect workers from the hazards of electricity and to ensure that they can return home safely each day. Therefore, ongoing education and training are critical components of a successful electrical safety program. Employees should receive regular training on electrical safety hazards, safe work practices, and the proper use of personal protective equipment. Training should be tailored to the specific tasks and hazards that employees are likely to encounter. In addition to formal training programs, it is also important to provide employees with ongoing safety reminders and updates. This can be done through toolbox talks, safety newsletters, and other communication channels. by providing employees with the knowledge and skills they need to work safely with electricity. Organizations can significantly reduce the risk of electrical accidents and injuries. To summarize, ensure comprehensive training on electrical hazards, testing procedures, personal protective equipment, and emergency response. Design work areas with isolation, barriers, prominent warning signs, adequate ventilation, and proper grounding. Adhere to standards like ANSI/ESD S20.20, ANSI/TI 942, and ISO 61010. Develop internal safety protocols with specific requirements for PPE, work area design, training, and emergency response. Regularly inspect equipment, implement lockout/tagout, provide first aid access, conduct safety audits, encourage reporting, investigate incidents, use calibrated instruments, ensure adequate lighting, and maintain current procedures. Promote a safety culture with visual cues, physical barriers, ongoing reminders, and leadership commitment. Conduct arc flash assessments, use arc-resistant equipment, and provide appropriate arc flash PPE. Continuously educate and train employees.